So hello viewers and welcome back to another video on networking. So in today's video we are going to take a look at the ARP protocol. So the full form is Address Resolution Protocol, and we'll see that how it works, what is the importance of having ARP. So that's it. So let's start the video without wasting much time. So following our previous videos, we'll have this pretty much the same content delivery format. First we'll have introduction, why we need, and how it works. So these three topics we'll see in today's video, and in later on videos we'll see the packet formats, simulation in CPT and simulation in NS3. So we'll cover topics in this way. First in today's video we'll cover these three topics. So let's get started with the introduction. So the full form of ARP is Address Resolution Protocol, and as the name suggests, it is used to map the IP address to MAC address. So I think you might be familiar with the most of the terminologies that we use in the networking. So IP address is logical address and MAC address is the physical address of network interface or NIC that we have in in our machines, and that is MAC address is always different or unique across all the devices that we have in the world today, but IP address can be same. So these are the facts that you must know before we start with the ARP. And as in the introduction of the ARP, it helps the end devices or the networking devices to build the ARP table. Now ARP table is something which maps the IP address with the MAC address. So that's the use of ARP table, and that relies or that falls between or between two layers of networking. So layer 2 data link layer and layer 3 which is called network layer, if we follow the TCP/IP network stack, right? Now it is automatically triggered. So ARP protocol, it is automatically triggered when packet is reached at network layer, and we don't have any MAC address for MAC address binding for particular destination IP address in the ARP table. So that is the particular case, or let's say that is the one case. There might be multiple cases for ARP to run, but that is the one of the mostly, or you can say one of the mostly invoked reason for ARP protocol. Now as I said, it works at layer 2 but provides the critical functionality for layer 3. That's why people often say that it works, or it has the connection between layer 2 and layer 3. It works at both layer, but usually it is layer 2 protocol, but it also serves the critical functionality for layer 3. So these are the facts, and you should be aware about this. So that concludes our introduction part for the ARP. So now let's see why we need ARP. So before we actually get to know the reasons why we need, here are some of the facts that might solve your question or doubt. So this is the IEEE 802.3 Ethernet frame format. So you can see that we have a lot of different fields: preamble, start frame, destination address, source address. So here these are length, data, frame size. So these are the frame, or these are the fields in the IEEE Ethernet frame format. So we need MAC address for the Ethernet frame. So here destination and source addresses, they will be MAC addresses. Now before this we can't build the next layer header, so that's why obviously we'll need this. And now IP is where the device is. So here are literal how I remember the stuff. So IP is usually terminology which states that where the device is in the network. Now MAC address or MAC, it states that who is the device in the local network. So these are the few terminologies. That's why that can relate you with the fact that why we need MAC address, because without it we can't build the Ethernet frame format. Now we can also have some brainstorm activities that so in the modern networks now we have wireless networks. So you might have a router in your home, and that might have some MAC address and IP address. And now when we have dynamic networks totally, so that means that our mobile phones are connected to this access point which is there in your network, which is there in your home, It has DHCP running on top of it. We'll also cover DHCP in upcoming videos, but DHCP is something that assigns the IP address automatically. Now, all the mobile phones that you have in your network, so there is no need to, for you to dedicatedly connect your mobile phone with your Wi-Fi router, right? So it is like proper dynamic. You just need to know your SSID and password, and based on that you can connect to a network and disconnect to a network. So based on the fact that in today's world we have the dynamic networks, ARP provides dynamic and automatic resolutions. So what this means is, if let's say these two mobiles were to communicate with each other, and following the fact that we have the dynamic networks, this phone might not be there when this phone wants to communicate to this network, this particular destination mobile address, right? So that's why ARP provides dynamic and automatic resolutions for IP addresses, right? So that's the basic need of having ARP, because without it we can't send we can't send our destination packets to this particular device. So that's why ARP is important to have. Now the third brainstorm is to this is another fact. So at each hop, so let's say these are the routers and they are connected through some link or some cable links, right? And each link or each hop, each of this path, as following the fact that these all are the routers, we can see and we can observe, and we'll also have this activity in the CPT, that each of this hop will change the MAC address binding, but the destination address of the packet will remain same. So that is the fact, because IP addresses are logical and MAC addresses are not logical, they are unique. So at let's say this device will send the packet to this device, so in between this path, the destination MAC address for the packet is of this MAC address of this router. Now let's say this device will send to this, then the destination packet, destination MAC address for this path is the MAC address of this device. So that's why for each hop, MAC address will change in router. So this is one of the fact that router routes the packet based on the IP, but forwards the packet based on the MAC address. So that's why we also need ARP. So ARP basically binds the MAC address for the particular IP address. So that's why this is one of the most known fact to all the people. Now let's get to know about something, some useful stuff about the MAC address. So MAC address is, the full form is media access control, and it is layer 2 identifier. It is 48 bits long, or you can also say it's 6 bytes, and 3 bytes is equals to, so this 6 bytes are divided into 2 parts. So first 3 bytes are vendor ID, which is called OUI, and the full form is organizationally unique identifier, and the rest of the 3 bytes are NIC ID or device ID. Now how this works is, so here I have an example. So let's say Cisco builds the network interface card. Cisco is more known company, right? It's very famous. Now let's say they build NICs. Now they will need to opt for OUI, which is uniquely identifies Cisco MAC addresses, Cisco manufactured NICs. Now let's say they have AA. So these are the first 3 bytes of MAC address of the NICs that are manufactured by Cisco. Now combining with this, we might have the starting MAC address from 00000 to FFFFFF. So that's how, combining these two MAC addresses of Cisco manufactured NICs will have addresses like this, all A's followed by all zeros up to all A's followed by all F's. And this is how OUI or MAC address works. And if all the bytes, all the bits are ones, so that means FFFFFF, right? All are F's, then that means it's a broadcast MAC addresses. So these are some of the facts and stuff to know about the MAC addresses. Now let's see how it works actually. So let's see how ARP works. Now this is also one of the brainstorms. So let's say this is a switch, and these are the interfaces: Ethernet 1, 2, and 3, and these are all three devices, and these are MAC address and IP addresses of all the devices. They are listed over here, right? We have shortened the MAC address just to simplify the learning, right? Let's say this device, which is having MAC address A and IP address 192.168.10.1, and let's say this wants to send to packet to 192.168.10.3, which is here, which is having MAC address C. Now it prepares the packet, and as you can see, it doesn't have any IP address, and so this is basically ARP table for this device, and you can see there are no entries for IP address mapped with MAC address. So let's say we prepare the packet, but as you can see, source IP is 192.168.10.1 because this is the device who is sending, and it knows that destination IP is 192.168.10.0. Now we don't bother about from where this machine got to know about the IP address, but there might be a DNS working to resolve the IP address. So that that protocol also we'll see in the later on our upcoming videos. But right now just focus that these are the details. Now source MAC it knows because this is the device who is sending the packet, so that's why source MAC is the MAC address of this particular device only. So that's A. Now the fact that it doesn't know MAC address of the destination machine, and it doesn't have any entry in the ARP table, it puts the destination MAC addresses all Fs. So that's the broadcast MAC address. And this packet, usually when we capture it inside Wireshark, it has this translation which says who has 192.168.10.3 tell 192.168.10.1. So that means whoever has this destination MAC address of particular this IP address, tell that to 192.168.10.1. So as you can see, this sends the broadcast. That goes to switch, and switch then forward the packet to all the ports except the port from which it has received the message. So from here it received the message and it broadcasted to Ethernet 2 and 3. Now as you can see, this machine rejected the packet because of the fact that it doesn't have the MAC address C, right? So this message got discarded because the destination MAC did not match, or the IP did not match. Now we can say that this machine received the packet, it analyzed the packet, and it saw that it's a ARP request. Now here you can see that from the Ethernet 1, so this is the what you can say MAC address table for switch. So once this device sent the package, the switch got to know that Ethernet 1 is connected to it is connected with the machine that has MAC address A. So that's how switch also learns that which devices are connected, which MAC addresses are connected to which port, and it internally maintains this table. Now this device got the packet, and it accepts the packet because the destination IP matched with the particular device. Now in the ARP request, this machine will prepare a reply, but you must notice that the reply is unicast. The request was broadcasted, but the reply will be unicasted. Now you can see the parameters over here. So this is the ARP table for this machine, and you can see the IP address 192.168.10.1. It got mapped with the MAC address A because the packet has that information. So that's why this machine learns and make the entries accordingly in the ARP table also. Now note the packet format or the information. So destination MAC is A because this machine need to receive the ARP reply. Source MAC is C because this machine is sending the reply. Destination IP is 10.1 because this machine is receiving, and source IP is 10.3 because this is the sending, right? So you just map how it works. We'll see all these details and packet formats in details in next videos. Now as you can see, this machine had reply, and this is the port and MAC address. So this is the what you can say MAC table for the switch, and as soon as this machine sends the reply, you can see it also learns that Ethernet 3 has the MAC address C. Now you can say this is the ARP table for this machine. Once this machine got the ARP reply, it also made the entry in the ARP table saying that 192.168.10.3, this machine's IP, it has MAC address C. So that's how these two machine switches and all the devices that are in our network maintains ARP table and MAC table. And that's how ARP works in the backend. And it helps to prepare ARP table and MAC table. So that's the overall working of ARP. So that concludes the basic overview of what you can say ARP protocol. I hope you have got the idea about how it works and why it is important. So this section which says packet formats, that we'll see in the next videos. So yeah, subscribe to our channel if you are new to this video, and if you want to learn more amazing videos on networking like that. We have so many videos already covered covering NS3. If you have not watched that, just watch the playlist, or I'll just put the I button link over here. And that's it. We'll meet in the next video. Till then, keep learning and keep exploring.